Forta. I want to welcome everyone to the first Forta Agent Development Workshop. Today's workshop will be hosted by our friends at Arbitrary Execution. Arbitrary Execution has been building Forta agents since Forta launched in private beta over the summer. They've also worked very closely with many of the DeFi projects that are onboarding to the network right now. So really happy to have them as a host today. Two housekeeping items before we get started. One, this session will be recorded. So if you cannot stay for the full hour, we will make the recording available in the next few days. This is also going to be the first of two workshops. Arbitrary will be hosting part 2 of this next Thursday, also at 11 a.m. PST, so literally a week from now. So don't want to miss that part 2 of this workshop series 2. Part 2 is going to be more of a deeper dive into the actual development process and build a sample agent. And you can see them sort of work live. So with that, I will pass it off to Kevin and Philip at Arbitrary. Thanks, guys.
Cool. Thank you, Andy. Yeah, so as Andy mentioned, we are from Arbitrary Execution. Certainly represent our teammates over at Forta. We're proud to be a part of this effort. We are going to walk you through the process that we use at Arbitrary to develop some of these scan agents, try to give you some tips, maybe some gotchas that you should look out for, but really just walk you through kind of start to finish of what it looks like to make a really well thought out and thorough scan agent for Forta. So a little bit more about us. We are Arbitrary Execution. We are a Forta development partner. We have been working on the Forta SDK since the beta release, as Andy said, back in the summer. We've worked on a number of agents for some pretty big deployed protocols you may have heard of. I've got a number listed here. I don't need to read through those for you. You can certainly check those out. We are working right now on an agent suite with Visor Finance, and then we have some private agents that we're working on. So can't give too many more details about that, but that is a thing. We can talk about that more in kind of a Q&A at the end. The main thing that we want to show you here is as we've gone through this development process for all of these agents and all of these protocols, this iterative process has shown us the things that really do work, the things that really don't, and then some patterns that have kind of emerged as far as things that are common across protocols, things that are common to agents, kind of best practices. And we'd like to share some of that with you now. If you are new to Forta, if you don't know what an agent is, and this sounds kind of foreign to you, an agent is really just it's a program. It's a script, either in JavaScript, TypeScript, or in Python. And these are agents that are constantly running, and they're looking for anything suspicious that occurs on the Ethereum blockchain or soon to be EVM compatible blockchains, layer 1, layer 2, et cetera. So we're looking for transactions that look out of the ordinary. They look anomalous. Something's weird about them. That's what the agent is looking for. Or if there's some huge change in the value of a contract, value stored, or some huge transaction on a smart contract. That is what agents are here to do. They are the runtime security for decentralized finance. So Forta doesn't sleep. Okay, you need to sleep. I need to sleep. But Forta doesn't. So these agents are always running, and every time another block is mined, every 13, 14 seconds, these agents are running against them to look for these anomalous things. If you go to Forta Explorer, I'll show the link later on. There are currently 237 active agents that are scanning different things in these blocks that are mined in these transactions. Perhaps soon your agent can be out there, and hopefully this will help you get to a place where you can publish some. I do want to give a quick shout out for the Forta Agent Developer Contest. It's a great way to get involved, and there's a really good opportunity there to possibly win some NFTs or win some crypto on the other side if you come out with a really slick agent that works well. I encourage you to join the Forta Discord if you haven't already. It's a great place to see the announcements for these things, and so hopefully soon you'll see your name as one of the winners of those contests. I've got the entire process that we go through. This is probably 50,000 foot view of the steps we go through when we develop agents here. We start with the requirements. What is this agent supposed to do? What are we looking for? What is the protocol? How does it work? Create. So we're actually doing the software development in this phase. This is where the bulk of this talk is going to occur. We need to test them. We need to make sure they work. After we have kind of convinced ourselves individually that they work, we pass those on to other seasoned developers, other people who are who know their stuff, and we submit it for critical review. This is a critical step. Then we go on to where the rubber meets the road, and we actually push publish. We put this agent out there to scan live as blocks are mined. So that's really the exciting part. And then we don't want to forget that as these agents are running, updates may need to occur. We may find a bug. We may have a new feature we want to add to an agent that's already out there. So we need to maintain them. So I'm going to go through each of these in a bit more detail. Please collect your questions if you have any, and we'll try to get to them as best we can at the end. So when we start with the requirements, we want to know, what is it that we're trying to do? So if you're in communication with a protocol team, say Aave or Uniswap, they may already know what they want to scan for. They may already know, here are the events that would be a big problem for us, or here are the events that we want to know about when they happen, as soon as they happen. So the protocol team may provide that directly to you if you have a line to them, or maybe you can propose some to the protocol, something that you're familiar with based on a previous exploit or some other thing, some other quirk of the protocol that you think would be interesting or important to monitor. There are some common tasks that basically all of the protocols are going to have that you could kind of make a generic agent and kind of do like a Mad Lib style fill in the blank for that. So these contracts are owned by somebody, either an admin, a governor, an owner, however it's labeled. And those owners or those admins are going to be able to perform functions on those contracts that other people aren't. So changing the ownership of the contract, maybe changing the fee rate of a contract. You're going to want to know when those happen. Those are important, especially if somehow somebody got your private key and is causing things to occur that shouldn't be. We want to know about the externally owned addresses for a protocol, and are they performing transactions outside of what we expect? Are they doing more than deploying just contracts for their protocol? And if they are, what are they doing? So that's going to be common across all protocols. If there are these large changes in value, so did somebody suddenly drain $30 million from a Uniswap pool? That's an important thing. We're going to want to know about that. Pretty much everyone participating in DeFi is going to want to know about that. And then there are some function calls, maybe some low-level function calls that don't spit out these events, that don't emit these events, but are critical nonetheless. You're going to want to know when those occur. And those are going to be common across all of these protocols that we're talking about. And then depending on the complexity of a protocol, they may want something like, they may want to identify when a liquidation opportunity exists. They may want to identify when there's an arbitrage opportunity. And so really kind of developing bots. So Forta allows that capability where you can have effectively a bot running as an agent to trigger on these and raise alerts like, hey, these values are getting kind of out of whack. There's a good opportunity here, or maybe something's going wrong with the protocol because that shouldn't exist. And then price oracles. There are far too many exploits that have to do with price oracles. So just critical to monitor that and spit out an alert if something funny is going on there. This is a checklist that we have before we even start putting kind of pen to paper, right? Before we start writing those agents and the code, you really need to understand what the requirements are. And this can take a while if it's a pretty complicated protocol, but it's well worth it because it will save you so much time when you actually develop that agent. There are a wealth of resources for protocols out there. I encourage you to find the developer documentation links, find the documentation links on all of these protocols, find their GitHub pages, any NPM packages, document all of this and keep it in a central location so you can refer back to it as you're making the agent. It will save you so much time and you'll be glad you did it. There's also this registry that a lot of these protocols participate in called Everest. It's good to look up that ID and include that as something you submit when you raise an alert. That really helps people drill down to, okay, who does this alert apply to, and how can I dig in a little deeper? You're going to want to identify all the contracts that are in scope. What is covered by this agent, and you're going to want those addresses. Externally owned addresses, keep track of those as well. That may come in handy for some of these transactions where they shouldn't be doing something, but they are. For deployed networks right now, Forta supports Ethereum Mainnet, but they're absolutely focusing, and I'll get into a little more detail on it. They're absolutely focusing on extending that to other chains. I've mentioned Avalanche here as well, but certainly in the future, you can imagine Polygon and any others that are out there. But know what network you're going to be scanning. And then, has the protocol requested a private alert? Is there something that if it were broadcast to the world would really cause a problem? And if so, how can we keep those alerts private? How can we obfuscate the code so that it's not trivial to just read through and see, oh, whenever this happens, I should probably throw all my money into this protocol, kind of YOLO, and see if I can make bank off it. Moving on to the create step. So when we start software development, we do need to do some planning ahead of time. The easy one, the low-hanging fruit, is what are we going to write this in? I've mentioned Forta supports JavaScript, TypeScript, and Python. We have done both JavaScript and Python, so we have a lot of examples in our code repository. I encourage you to check it out on GitHub. And so what am I most familiar with? What is my team most familiar with? Know what language you're going to start with, and then try to plan out how many agents do I need to accomplish this task. Maybe they've asked me for 10 different things that they want to monitor, but they're all very similar. If they are very similar, then it's possible you can have one agent that can emit multiple alerts based on those 10 conditions. If those 10 conditions are very dissimilar from one another, it may make more sense to write separate, what we call handlers. So basically kind of like separate JavaScript modules or Python modules for each of those 10 tasks, and then have a central module that kind of collects all of these alerts to send on to the scan node where the code runs. We typically have grouped all of our handlers together, our separate modules together, into what we call agent suites. And that really simplifies and helps us when we publish, and even more so when we want to maintain and either add functionality or make any bug fixes that we find. So that's kind of this critical planning step. Just blueprint, how many do I think I'm going to need, rather than just diving right in. When we set up the repository, we highly recommend, if you haven't done it already, to look at the Forta Agent Examples repository. It's a good place to start, provides a pretty good framework for what your repository could look like, both for those kind of single agent cases or the multiple agent, multiple handler agent suites that we were talking about. Please, if you're going to go through with this endeavor, and I encourage you to update the fields in your package.json, just give your agent a name, start with 0.0.1 for the version, make sure you lay out the packages that are required. Think of if you were running somebody else's code, you'd want to know some details about it ahead of time. And package.json is that great collection point for all of your NPM install needs. So be a good neighbor, do that. As far as the shared resources, you might have these multiple agents, and they're all going to need access to these addresses and these ABIs for the contracts. It's good to keep those in a central place, whether that's a central directory, maybe a few data files like JSON files that all of your agents can access. Some of these protocols will provide an NPM package. We encourage you to go that route, because those will give you up-to-date addresses and up-to-date ABIs in case anything does change. Or you may have to go digging in the GitHub repository for that protocol. And then please also use Etherscan or other blockchain explorers. They are great resources. A lot of times they will have the ABI published there, as well as the contract source code that was compiled for the contract that's actually deployed. We spend a lot of time on Etherscan as we start going through the development of these agents. If there's anything that you need to run your agent that is outside the source directory, update your Docker file. You'll be glad you did, because it's a rude surprise to find out that your Docker image or your Docker container is not running because you forgot to copy something into it. So just make sure you get everything in there ahead of time. And then also maybe some common configuration parameters can be stored in another JSON file. We do this because it's easy for the protocols to see where the thresholds are stored. So do I trigger on a $10 million value? Do I trigger on a $50 million value? How do I kind of turn the knobs on this agent if I want to? It really helps a protocol and a team to look at your stuff and know very, very quickly, how to turn those knobs. And again, the protocol Everest ID, please include that as well. It really just saves a lot of time once the alerts start coming. So there are two principal ways that you are going to make your agent. Are you going to process transaction by transaction? So all the transactions that occur in a block, are you going to be looking for those events, looking for those functions? If you are, then the handle transaction code pattern or the handle transaction functions or the way you're going to want to implement that. On the other hand, if what you're looking for is changes that occur block to block, but may not specifically be from an event that it's emitted or some function that gets called, you're going to want to use handleBlock. That will allow you to dig down in and see, did the account balance change? Did the liquidity, the amount of liquidity change from that block to this one? And that's basically going to be this periodic trigger that at this point, I think I last saw it was like about 13.7 seconds, but yeah, on the order of 14, 15 seconds that you're going to get that update to check, did something change? Did something change? So these are kind of the two main code patterns for scanning events or scanning transactions and blocks. As I said, you want to know where this is running. What blocks is this running against? Right now, as I said, Forta supports Ethereum Mainnet. So that's where the scan node, which is where your agent is going to be running, that scan node is going to be pushing those blocks and those transactions directly to your agent. So that's kind of the principal mechanism. Every time a block is mined and that block is made up of transactions, that's going to get pushed through into your code, and your code gets a chance to run through and look for those suspicious or anomalous events. It is absolutely a top priority. We have had a number of conversations, as have the other development partners, with the Forta team about, how to move into another network and what that network's going to be. So that is absolutely in the works right now. So look for that, and again in the Forta Discord when those announcements get made. That'll be good. Then also, currently, for any networks that aren't supported yet, if you have a JSON-RPC URL or API that you can hit to make JSON-RPC calls, you can do that. The Forta agents allow it, but note that it's a bit of a workaround for the moment. So we've called it a hack. Maybe that's an uncharitable way of calling it. You will be able to access that information. You will be able to scan that, but they will not correlate with the links that are provided in Forta Explorer right now. So again, look for more updates on that. This is continually improving. We're glad to be a part of that and helping that improve. But that is an option to you. If you need to reach out to any external APIs, maybe you want to reach out to CoinGecko and get a price from there. Maybe you want to reach out to Etherscan to get an ABI or code or other things. Forta agents do allow that. And so you can open an external port, you can make some GET requests with something like Axios, or if you want to go a little bit lower down and do a fetch, you can do that. But you need to be wary of how many requests your agent's going to be making for each block or each transaction, and compare that to what the limitations are of the service that you're using. We absolutely, as wholeheartedly as possible, do not use any external API that requires credentials, API keys, anything you pay for. Do not include that in your agent, because when this gets deployed, this is going out into the wild. You don't run the scan node, you don't own it. Who knows how many requests are going to get made. We highly recommend using whatever free tiers or publicly available endpoints are available. Go that route. Don't submit your creds. That's just good advice in general. But you can make these requests, you can check things externally, and you can include that in your logic. We want to give a special shout out to the ethers.js JavaScript library. I mean, this is your bread and butter right here. So there are a lot of functions that are built into it, a lot of classes and objects that really make this a lot simpler for any EVM compatible blockchain. We've used this obviously with Ethereum, which is the easy one, but Avalanche we recently did some work for, which is EVM compatible and works the same way. It's fantastic. I've labeled out a few of those right here that we use quite a bit. Parsing, the parseLog function that allows you to basically extract important information from these events as they come through. Something that just went into ethers recently called the JSON-RPC It's not actually in the documentation yet, as far as I can tell, but if you dig into their pull requests, it was included recently. This is a fantastic thing that will actually take many JSON-RPC calls and batch them into a single HTTP request, and it's constantly running in the background. So it's this beautiful, transparent way of kind of saving on your HTTP requests, so you're not hitting those limits as quickly. Contract, I think that's a pretty straightforward one. This is how you're going to interact with those contracts that are deployed on the blockchain. For your own sanity, being able to format values that come out of ethers, format ether is fantastic. And then for whenever you want to take a value and put it back in, parse ether is kind of the opposite operation. That'll really help you with this encoding and decoding, so that you're not frustrated about what this hex value is in front of you. And then for tests, which I'll get into more, there are some really great kind of primitives in there for writing tests, for kind of mocking out or representing hashes and addresses that can really help you streamline your tests and make them look slick. We have a little bit of work that we've done in Python. There is a Web3 package there, so we would point you to that if that's your flavor of programming that you prefer. But one way or another, these libraries, these Web3 libraries are indispensable. And now kind of at the edges of what we've done, we've had an opportunity to do some pretty unique things in these agents, and we look forward to more of it. But as you start to test the limits of what you think an agent can do, you'll find you can actually help extend it. So for outliers in data, statistical outliers in data, well, what defines an outlier other than knowing what a lot of the data looks like already? So we have a rolling math library that we've put out that basically keeps track of this kind of moving average. And every time another value comes in, it's able to compare that value to kind of this history of data. You can kind of envision, the stock market typically goes up and down quite a bit in any given day. You're not so interested in those ups and downs. You're interested in anything that's really outside that regular variance. So using a moving average filter kind of helps with that process. If you have something that's going to take longer than the 13 or 14 seconds between blocks to do, you can set up basically an asynchronous process that's going to be running continually. And then every time a block comes in, your handleBlock function can kind of check on the status of it and say, is it done yet? Okay, if it's done, submit some findings. If it's not done yet, just wait until it is. And if it's finished, kick it off again and start over. We had one of those recently where we had to scan thousands of positions, and it just wasn't going to happen in 14 or 15 seconds. And so we basically check it each time a block comes in, send up the findings when they're submitted, and then kick off the process again. And then I can't say this one enough. Please be a good neighbor. Do not spam alerts. If you're going to come out with an agent that you expect or have any idea that it might send out an alert every block or every transaction, heaven forbid that, consider finding a way to limit the number of alerts that are emitted. It does nobody any good if we have like the boy who cried wolf, and these things are just sending alerts out, because then nothing looks like an alert. It's just spamming constantly. So if you're going to expect very frequent alerts, consider limiting that to maybe, some number per hour or even some number per day. We had an alert that was going to fire every single block because the condition was always being met, but it needed attention from that protocol. And so we came up with a way of tracking how many events would have been emitted over a day. And at the end of that 24-hour period, we submitted one finding that said, look, here's your finding, but I would have submitted however many, 2,000 if I had submitted constantly. Moving on to testing. So please test your code. And the way to do that initially is going to Etherscan, going to another block explorer, and finding those transactions that should trigger an alert from the agent that you're writing. Etherscan has some really great facilities for being able to drill down to the contract you're interested in, the events that come from it. Sometimes they'll even label some of these, transactions that are exploits or anything like that. So find that transaction hash and use that as you're developing your agent to see, is my agent sending up an alert from this transaction, which I know it should. If you have something that you expect an alert to be emitted for frequently, it may be enough just to run the agent from your terminal. And after a minute or two, you may have some transactions already. Go ahead and save those transaction hashes and use those in testing to make sure that everything is still happening the way you expect it to. And as I said, again, Etherscan, I'll probably say the word Etherscan almost as much as Forta in this talk, but Etherscan is a really good tool to use, and other block explorers are really good for digging down and finding, the events that should be triggering your agent. Unit tests are an absolute necessity. Every agent should have. So if you have an agent that is made up of a bunch of handlers, all of those handlers should have unit tests. You need to be certain that when you run your code, if it's emitting an alert, if it's submitting an alert to the scan node, that it's doing it for the right reasons. Or if it's not submitting alerts, that's also for the right reasons. So your unit test should provide positive cases where I know under these conditions an alert should be submitted, and then negative cases where I know for certain it shouldn't be submitted. Edge cases can be really tough to find, but are again very critical. What happens if a divide by zero comes in? What if I didn't think about that? Does the whole thing crash? What if I have the right event topic, but it's not from the right address? I need to be able to say my agent is not going to trigger on that, or my agent is not going to just go belly up. Mocking is an art form, but you need to mock all of the external modules that you're using. During your test, you should not be reaching out to the world. You should not be reaching out to the internet. You shouldn't be reaching out to websites and JSON-RPC providers. That should all be mocked out in your tests. And you should be able to simulate that so that you know exactly what's coming in for each of your test cases. Something we've run into is it's very easy to get a false sense of security when you don't hard code your test case values. The situation that can occur is I run my agent, and that's a piece of code. I run another piece of code that will generate my simulated finding, and I compare the two results. Well, what happens if they're both not working and they both give you undefined? Well, now your test passes, but you didn't know it. You thought it was all good, but it wasn't really. So we recommend hard coding the expected value that your agent should return for each of those cases and asserting or doing an expect against that to make sure that you're not passing tests improperly or incorrectly. Before you send this off to your colleagues, to your team, to the world to review, go ahead and do your own sanity check. If you don't already use a linter, please use one. It is a great return on investment for finding syntax errors, for finding bugs, for finding the way that you're doing a particular while loop or for loop or a map in JavaScript. But that's not really the way that should work. That's not how any of that works. So a linter will save you a lot of time and a lot of headaches by finding these very quickly. We use ESLint for our JavaScript agents. It also works on TypeScript. If Python's your flavor, PyLint is there for you. And then if you don't already have a good sense of your coding style, your naming convention for variables, stuff like that, please consider using a formatter. I know that some of the people who have submitted to some of these agent contests use Prettier. If for JavaScript or TypeScript, if Python is what you'd rather go with, there's a package called Black that does the same thing. And I'm going to sound like a broken record here, but I think it's totally worth it. Run your agent against known transactions. Does it work? Just sanity check. Did it do what I thought it was going to do? Run your tests. Do the tests pass? or do they not? All your tests should pass and your agent should trigger on transactions that it's expected to. And from here, we let the agent out of our hands as a developer, and we put it into the hands of our teammates, our colleagues, other people who are familiar with it. And we say, please critically review my code, my tests, please critically review all of this. The way we do that, all of our work is in our GitHub repository. So we submit pull requests against it. And then our team does code reviews. We typically work in a team of 3 or 4 people. And so we require that before a pull request is approved, it needs to have eyes on and been combed through by 2 of the other developers, and they need to give their approval. As they submit comments, as they submit suggestions, it's up to you as a developer to either accept those, and that's kind of the easy case, like, oh, hey, great, you caught a bug, you caught something I didn't see. Or if you have a pretty good reason for doing things the way that you did, provide that justification when you say, hey, thanks, I'm not going to take your suggestion. It works this way for a reason. But this is absolutely critical. It's a critical thing for you to be able to review other people's code. And it's also critical that other people put eyes on your code. It will definitely make both of you better coders, or multiple people better coders, kind of as iron sharpens iron, so to speak. So we're getting close to the magic moment where we publish this agent. But before we do, one more sanity check. Before you hit publish, you should go through this checklist. Did you update the README? If you saw this README for the first time, would you be able to say what the agent does? Is there a complete description of how the agent behaves, a complete description of the alerts that are emitted by it? Is it concise? We don't need a novel. We just need something that explains what it does and no more. If it's a private agent, we're basically going to redact all of that information from the README because we don't want prying eyes to know what this agent is doing. But we will make this private README. That's our recommendation. And we'll leave that out of the Docker image. We won't copy that in to the image when we create it in the Docker file. But this will be a reference for the protocol to see, okay, what is this doing? They still need to have that kind of map of what this agent does. You need to know who's going to maintain it. So it could be you. You could be the one, you could be the one publishing the agent and then also maintaining it. Or it may be that you hand it off to the protocol and the protocol says, well, thanks, we'll go ahead and publish it and we'll do the maintenance from here on out. So communicate clearly, make sure you know what's expected of you and of the protocol that you're working with. And then I think this is the 3rd or 4th time I've mentioned it now, but you get the idea of the importance of these steps. npm start is what you're going to run your agent and see, is it running? Hopefully it doesn't crash. Hopefully it emits the appropriate alerts. npm test is running against your tests, your unit tests. They should all pass. Go ahead and build your image. You're going to have to anyway before you can publish it, and then run it. Make sure it's running. If you have the capability to log into your running container and see that the process is still running, do that as well. Like, this is the last step before you kind of release your baby out into the world. So make sure that you do your due diligence here. And now the magic moment, as I said, we're going to publish. The Forta documentation is really good on this point. There are kind of 2 sets of instructions mainly on how to do the publishing. You can do it through the command line interface or CLI. You can also do it through Forta Connect. We highly recommend Forta Connect. It is very streamlined. It's almost just as easy as the click of a button. It's fantastic. We highly recommend it. We've got a few points here, a few reminders. It seems like it might be pretty straightforward, but make sure that you're submitting the correct Docker image. Okay, so just do your double check. It should be this. Okay, that's what I'm submitting. Please provide your repository URL. It's a lot easier for somebody to look at your code, see what it's doing, provide scrutiny, maybe even find a bug if your code is just out there and available in the repository versus trying to pull down your image and dig into it. Okay, so always provide your repository URL and the correct Docker image. I put this last point on here for those of you doing TypeScript. TypeScript is naturally going to use the transpiler to turn it into JavaScript. That JavaScript is not really fit for human consumption. So if you are a TypeScript guru or a TypeScript programmer, consider just copying that into your image so that if somebody goes that route, they can look at your image, they can dig in, and they can see the original TypeScript code and have a prayer really of determining how the thing is supposed to operate. I've provided some links down here for the documentation. It's very good. It really, really helps you out here. And then Forta Connect as well, which we recommend. Now, maintenance. I think a lot of us want to fire and forget, right? We want to send our agent out and just assume it all went according to plan. Well, we're humans, and it doesn't always go according to plan. So go ahead and periodically check to make sure that your deployed agent is doing what you expect it to. Do you expect it to send alerts frequently? Okay, go into Forta Explorer and see, are those alerts showing up? It may kind of be buried in some of the other alerts that are occurring, but there are some mechanisms there where you can search by ID, and other ways you can drill down to find your alerts to see when they show up. And then when you do find these bugs, whether it's you, whether it's the protocol, whether it's somebody else, or if you find new features that would really help this agent shine, go back in, fix the bugs, add the features, go through all the steps that we mentioned previously as far as, think about what you're creating, create your code, write your tests, etc. Increment the version number. This will be good. So you're not always submitting version 1 again over and over. And then go ahead and redeploy your agent. And again, kind of rinse and repeat. This is tried and true. This is the way that we found that things work best. And then I've provided the URL here for Forta Explorer, which hopefully you're familiar with. If not, I encourage you to go there and check it out. Now, some gotchas. There are more than we can include here, I'm sure, but these are the ones that have kind of risen to the top. Checked summed addresses. That may not be familiar to you, but I encourage you to look into it. The addresses that are coming through the Forta SDK are all going to be lowercase. So just to keep some kind of consistency, they're all lowercase. But the addresses that you might copy off of Etherscan could be lowercase. They could be checksummed. The addresses that you're going to get back from ethers, if you're doing these external JSON-RPC calls, they're going to be checksummed. The quick way to tell is in the hexadecimal representation of that address. If you see any capital letters in there, capital A, B, C, D, E, F, G, I'm sorry, E, F, not G. If you see any of those capital letters, that's kind of the giveaway that it's a checksummed address. That is going to cost you more time than anything else if you don't make sure that they're all consistently lowercase. And so we highly encourage, just go back through and look at that. Ether's big number, this one hurts my head specifically. Ether's big number is not the same as bignumber.js. Bignumber.js is the standard basically for this type of math. And yet Ether's helpfully or unhelpfully provides a similar mechanism, but they gave it the same name. They are not compatible. Don't try to intermix them. You're going to have a bad time. Also, bignumber.js is much more thorough in what it can do. It does handle divide by 0 with an appropriate, not a number, stuff like that. My encouragement to you is if you're going to be doing math, a lot of computation in your agent, convert all of your return values from any contract calls. Those are going to be in Ether's big number. Convert those into bignumber.js. You will be glad that you did. The initialize code pattern is fantastic. Use it as much as possible. Basically, when an agent runs for the first time, there's going to be some code that runs before the agent starts running. And this is referred to as the initialize code or provide initialize. These are the ways that we provide it. Do as much of your work there as possible. If you have contracts to set up, if you have interfaces to set up, whatever needs to be set up for your handler to function, set it up there, and then let your handler be much more streamlined. Do not go the path of setting up a contract every time your handler is called. There's just too much overhead in doing these things, especially as you spread it across lots of agents. So use that, use it well. It'll also make your life simpler in terms of writing tests because you've kind of segmented off your initialization code from your agent code. This is now the 5th or 6th time that I've mentioned this one. Find transactions that will trigger your agent. You will be glad that you did. I think I've beat that dead horse enough at this point. Lint your code. Good for you, good for others. It's a very simple step, great bang for the buck. And then look for good code patterns in publicly available repositories. So I'll humbly say that we have a lot of our code out there. Feel free to look at that. Look at Nethermind, look at LimeChain, look at the other Forta development partners who are out there. Absolutely start there. Don't start at zero. Start where we are and get better. And we're happy to have you look at that. If you see a mistake and you want to submit a pull request and find it, please do. We're happy to work with any who want to contribute. With that, that is kind of the end of the very, very long process, lots and lots of words. Apologize about that. But we look forward to following through with these steps in the workshop next week. We'll see how we can actually create an agent from scratch, so to speak, in about an hour. So please hold me to it, but I think it can be done. And with that, I'll turn it back over to Andy or Juan if you guys want to kind of moderate any questions that people have.
Thanks, Philip. Appreciate that. So I know Kevin was doing a good job of addressing questions as they were coming in the chat. I think one from looks like Zuhaib at the end. Basic understanding of Python and JavaScript is good enough to start writing the agents. Any other prerequisites required? I don't know who wants to take that one.
So it is not quite enough to just be able to write some Python and write some JavaScript. You are definitely going to need some familiarity with how the Ethereum blockchain works. There are a lot of tutorials out there for interacting with contracts. I would highly recommend looking at those. You're going to need some experience. But it should not take long for you to be interacting with contracts, for calling methods, for looking at values. So I would add that on top. You need just the smallest amount, just the modicum of understanding. And those code examples that Hasib has provided on the Forta agent examples, that's a great place to start. You guys have provided a very simple starting point to see like, oh, this is how I detect the amount of gas. This is how I detect a large flash loan. Work from examples. You'll be glad that you did. But you do need that little bit of familiarity to be just a little more dangerous. Yeah.
Yeah, that's like just to add on to that. Just looking at the Forta docs, you can get started right away, like Philip is saying, with basic checks. Like I want to know if in this particular transaction, is it an address that I'm interested in, or is there an event that I'm interested in? And the Forta docs will get you going with that and the examples pretty easily. But then there's just additional APIs that you need to have a little bit of understanding about, like the ethers.js API. We spent a lot of time talking about that. Being able to set up the correct JSON-RPC provider to take an ABI for a contract and set up an interface to the contract so you can make function calls in the contract. Just you have to read through the ethers docs to understand enough to be able to do those additional operations that become kind of common with writing more sophisticated agents.
Great, thanks, Kevin. Joel, I see you had a question about, not a question, but a comment about trouble testing with big numbers. If there was more there that you
yeah, Philip made a good. Oh, sorry.
Go ahead.
I was just going to say Philip brought up an excellent gotcha about the big number versus big number JS. In general, we try to keep numeric values either in big number or string. If you start using, these are fixed point numbers. You start using floating point or like parse float in JavaScript, it's going to screw everything up, and you're going to eventually have a bug. So just remember, do not try to use JavaScript floating point math. Also, there's just number limitations on the size of a number that JavaScript can inherently deal with as an integer, which is why we have to use big number.
And then Artem asked if the presentation file will be provided. I think we can share the PDF of these slides afterwards. Yep. Okay, and I guess if anyone else has any questions, you're welcome to take yourself off of mute too. Now that we're in sort of officially in the Q&A portion, don't feel like you need to type your questions in. Okay, well, if there is, oh, there we go. Thanks, Fat Bros. If there are no other questions for Philip and Kevin, I want to thank everyone for joining. I want to thank Philip and Kevin again for hosting such a great session. We will be posting the recording online shortly. I think we're going to edit it first, and then we'll make it available to everybody. And just a reminder, same time next week, we'll be doing part 2 of the Forta Agent Development Workshop. So make sure to join us next Thursday. Thank you, everyone, for joining.
I was going to say that that one will actually include a code walkthrough to help trying to put all the stuff we just said into perspective.
Excellent.
Such a great workshop, guys. And I just wanted to hop in. I'm Samuel, the community manager for Forta, and we have the last day or so of the 3rd contest, which is co-sponsored by Open Zeppelin. So if any of you on this call are feeling super inspired and ready to build an agent, we have an opportunity for you to do that. Some of the best agents that we've had, I've been conversing with the developers, and they've said, oh, they were able to put it out in like 4 to 6 hours. So, plenty of time left if you feel inspired and have the time this afternoon and evening.
Thanks, Sam, and thanks everybody again for joining. Have a great rest of the week, and we'll see you next Thursday.